This is the video for the Exam 2 practice test. All right, let's start with the first page. So, the first questions are asking us to simplify the exponential expressions. So when we're simplifying exponential expressions, the first thing we want to do is simplify inside any parentheses. So, if I look at this parenthesis here, I have 4x squared y over 3xy to the 7th. So the 4 does not reduce with anything. The x squared and the x cubed, the 2 subtracts into the 3. And same thing here, we have y to the 1st over y to the 7, that's y to the 6 on the top. Okay. Then we multiply that by the next parentheses that needs to be simplified. I have here 8, so that stays on the top. Then x to the negative 3, so a negative exponent goes down into the denominator. And then y to the 6 over y squared is y to the 4th. Okay. Now, after we simplify inside the parentheses, we need to apply any exponents outside the parentheses. I'm going to start with this negative 1. A negative exponent just tells us to flip the fraction. So to get rid of this negative 1, we rewrite that for it's x y to the 6th over 4. Now all to the first power, which you don't need to write, okay? Times, then we're going to apply the 2, the second power here. We're going to go 8 squared is 64. Y to the 4th squared is y to the 8th. And x cubed squared is x to the 6th. Okay, what we have then is two expressions that can be multiplied together. So we have x to the x, y to the 6th times 64 y to the 8th, all over 4x to the 6th. All right, now we're going to just reduce this and combine like terms. I always like to start with my constants. So 64 divided by 4 would be 16. Then I have x over x to the 6th is x to the 5th in the denominator. And then y to the 6th times y to the 8th is y to the 14th. Okay, we know that we are completely simplified because we have one of each variable, no more parentheses, no more negative exponents. So there we go. We've got it. All right. B is actually a little bit easier, but we're going to simplify inside the parentheses. So we have negative 15 over negative 30 is 2 in my denominator. Then I have x squared over x cubed is x on the bottom. Then I have y to the cube. I'm going to bring this y up so that it's cubed times 2, so that is y to the 5th on the top. So we simplify inside the parentheses first, and then let's distribute that exponent through. So y to the 5th to the 2nd power is y to the 10th. 2 to the 2nd power is 4. And x to the 1st to the 2nd power is x squared. All right, so that is simplifying exponential expressions. All right, these next couple problems are going to involve us just performing the operation they tell us. So we've got addition, subtraction, and multiplication. And we just need to do what they tell us. So the first one here, this addition, if we distribute any signs through here, we have, which we don't need to do on this one. I'm just rewriting them out without the parentheses. This plus sign distributes all the way through. From this point, let's just add like terms. So I have 7x to the fourth y and 9x to the fourth y, which would give me 16x to the fourth y. Then I have xy squared, that's plus 2xy squared. Then we have negative 5y plus 8y, which would be plus 3y. And we just added like terms, so that is our final answer. Okay, so for B, it's a little bit harder because we do have this minus sign through, or in front. So we've got 4x cubed y cubed plus 5x to the fourth y squared plus 6y minus 7x. And then here I'm going to distribute the minus sign through. On problems like these, they're not terribly difficult problems, but I see this mistake way more than I should. Not distributing a minus sign all the way through the second part of what's being subtracted. So I have negative times positive 6 is a negative 6x to the fourth y squared. A negative times a negative 5 is a plus 5y. And a negative times negative 7x is a plus 7x. So we just distribute that minus sign through and then start combining like terms. I have 4x cubed y cubed minus 2x cubed y cubed. And that gives me 2x cubed y cubed. Then I have 5x to the fourth y to the fourth minus 6x to the fourth y squared. Y squared. Which gives me negative x to the fourth y squared. Then I have 6y plus 5y is 11y. And then minus 7x plus 7x cancel out. So there's our answer. All right, C, we need to multiply here, so we're going to distribute. We're going to distribute that 7xy to the fourth to each term. So here on the first term, 7 times 5 is 35. X times x to the fifth is x to the sixth, and then y to the fourth. On the second multiplication, I have 7 times 3 is 21. X, y to the fourth times y cubed is y to the seventh. And there it is. Okay, D, now we need to FOIL or distribute. We're going to distribute the first term to both terms in the second. So 3k times 2k is 6k squared. 3k times 3z is plus 9kz. I like to write my letters in alphabetical order in each individual term. Okay, then we have negative 2z times 2k is negative 4kz. And negative 2 times positive 3 is negative 6z squared. All right, we just combine like terms and we are left with 6k squared plus 5kz minus 6z squared. And there we go. Let's move on to the next page. Okay, so on these next bunch of problems, we are going to factor completely. Okay, so what we need to do is first, let's look and see, is there a GCF? It looks like there is a GCF, but I'm not going to worry about it because there's 4 terms. What I'm going to do here is I'm going to factor by grouping. I'm going to group because there are 4 terms. So if I group my first 2 terms together, it looks like there's a common factor of 6a. And then we are left with x minus 2. On my second group, I have a common factor of negative 3b. Negative 3bx divided by negative 3b is x. Positive 6by divided by negative 3b is negative 2y. Sorry, I left the y off on my second part. Okay. So what we are going to do now is that we have factored the groups, common factor out. Each group has a common binomial factor. So I'm going to factor that binomial factor out. Okay, if I factor the x minus 2y here, we are left with 6a. If I factor it out here, I have minus 3b. Now, technically we're good. There is a common factor in this factor that can be pulled out. So if you do pull that out, you're great. Going way above and beyond. So what that would end up looking like is x minus 2y. Then I'm going to pull a common factor of 3 out, and that gives me 2a minus b. So either one of those answers is great. All right, on B, this is probably one of the easier ones here. But first, we look for a common factor between x squared, 10x, and 21, and there's not, which is great. Now, because this is a 1 in front of my x squared, I'm really just going to be looking for two things that multiply to get to 21 and add to get to 10. Positive, positive, so they're the same sign, which means we'll be adding the two numbers. And they're both positive because it's a positive 10. So we have, looks like it's 7 and 3. X plus 7, x plus 3. There we go. All right. On C, kind of the same idea. The very first thing I must do on C, though, is let's look and see if we can find a common factor. Here, I have 3x squared plus 18x plus 27. So there's a common factor of 3. Okay, so we're factoring 3 out from each term. We're left with x squared plus 6x plus 9. All right, you might see right away that that is a perfect square trinomial, like that. But if you don't, it's not that big a deal. You just are going to find two things that multiply to get to 9 and add to get to 6, which would be 3 plus 3. So then that would give us x plus 3 times x plus 3. Don't forget your common factor out in front. That would give us x plus 3 squared. Okay. Some nice basic factoring to start out. Now D is a little bit different because it has only two terms. So if our factoring that we're trying to do has only two terms, we need to check and see, can the two terms be broken up as perfect squares or perfect cubes or maybe even both? In this case, 36 and y squared are both perfect squares. So this is going to be the formula a squared minus b squared equals a plus b times a minus b. Okay, so my a is going to be 6y and my b is going to be 1. So that gives me a 6y plus 1, 6y minus 1. And there we go. All right, E was one I had a little bit of trouble with at first because it looks really weird and I factored out the GCF. So I'm going to start, but it's a little bit harder. So actually what I'm going to do first is I'm going to rewrite with my x, highest x first, and I'm just going to decrease my x power. Okay, the main reason I write them in decreasing power order is I know how to factor out my greatest common factor and if it needs to be negative or not. So here I have 30, 8, and 8. So my GCF, it looks like it's going to be a 2x. So we are left with 15x squared minus 4xy minus 4y squared. Okay, this has a term in front of our a now that we're with the one we're trying to factor. So I'm going to take this 15 and multiply the 4. Okay, so that gives me 2x times x squared minus 4xy minus 60y squared. Okay, let's come up here. I'm going to try and find my factors of 60. So what two things multiply to get to 60 and add to get to negative 4? Sorry, that should be a negative 60. Okay, factors of 60. And they're going to be opposite signs, which means we'll subtract them to find that 4. So we have obviously 1 and 60, 2 and 30, 4 and 15, and then if we keep going, we'll get to the 6 and 10. Okay, 6 and 10. 6 and 10. The bigger number needs to be negative. So I have x minus 10y and x plus 6y. Okay, now we factored it, but don't forget that originally I multiplied by 15. So I need to go back through and divide my factors by 15. Reduce those fractions. So 10 and 15 have a common factor of 5. So that gives me 2y over 3. 6 and 15 have a common factor of 3. 2y over 5. And then bring any of the denominators back up in front. Because we brought it to the back, we're going to bring it back where it belongs. 3x minus 2y, 5x plus 2y. And there we go. Okay, so a number f, letter F, tells us to factor, and we have two terms. So are they perfect squares or cubes? Well, it looks like these are both perfect cubes, so we have the cube formula. My a cube plus b cube formula is a plus b times a squared minus a times b plus b squared. All right, so what cubed gives me 125? That would be 5. And what cubed is z cubed? That is z. What cubed is 1? That's 1. I like when there's a 1. All right, so let's put them directly into the formula. So we have a, which is 5z, plus b, which is 1, times a squared, so 5z, I'm just going to write it out as it is right now, and then we'll go and simplify it later. So we have 5z squared minus a, which is 5z, times b, which is 1, plus b, which is 1 squared. Okay. I'm just going to clean this up a tiny bit. We have 5z plus 1 times 25z squared minus 5z plus 1. There we go. F is just great if you are really good at just plugging into a formula and going. G, on the other hand, takes a little bit more critical thinking. We do have that there are two terms and they are both perfect squares. So I'm going to use the a squared minus b squared. But in this case, my a, what squared is 81? That is 9. And what squared is x to the 4th? That would be x squared. For my b, what squared is 1? That is 1. So we apply the rule, which just says it is a plus b times a minus b. The problem here, well, it's not really a problem, it's actually kind of exciting, is that we can factor this one even further. So when I can factor further, I always like to write the term that cannot be factored more first. And then I'm going to try and factor this 9x squared minus 1. So my a is going to be 3x, and my b is going to be 1. So I have here 3x plus 1, 3x minus 1. There we go. We have it all the way factored. Okay, that's the factoring for the second page. Let's go ahead and move on to the third page. All right, let's start here with h on this page. So I have 4x squared y plus 12xy squared plus 8y squared. All right, there's a common factor of a 4 that I can pull out and a common factor of y. So that will leave me with x squared plus 3y plus 2y. Sorry, I forgot the x there. 3xy plus 2y. Okay, the funny thing about this one is there is no more factoring that can be done. I can't factor out if I have x squared, x, y, and then just a y. Yep, there's nothing else that looks like it can be done, so that happens sometimes. Sometimes there's just a greatest common factor that can be factored out, and that is it. Okay, and that's important to know even for the test, so make sure you know, okay, sometimes it's just the greatest common factor. No big deal. Okay, I is important. I need you all to make sure that on I, there is a typo. This problem should say something a little different. Really, we wanted it to say y squared minus 6y plus 9 minus 81x squared. You can kind of see the components in there. But this problem, I want to rewrite it for a very specific question on your test. All right. So what I'm going to do, if I factor 2 to 2, this will not work. We must factor this 3 to 1. And we're factoring by grouping because there are 4 terms. All right. So when we do that, we're going to factor this first one. The factors of 9 that give us 6 are negative 3 and negative 3. So that's y minus 3 squared. Okay, now we have y minus 3 squared minus 81x squared. That's an a squared minus b squared form, where my a is y minus 3 and my b is 9x. So if we put it into the formula, it's a plus b times a minus b. And once again, I just rewrote a new problem. I did not use the problem that was on the test review because I wanted to give you a chance to do a problem where we do this method. All right, J, we've got 14y squared minus 21y plus 7. So let's factor out the greatest common factor, which would be 7. Do not forget to factor the greatest common factor out before you try and factor it. So 14 divided by 7 is 2. 21 divided by 7 is 3 plus 1. Okay, so we're going to factor my remaining trinomial. I've got a 2 here. So I have 7 times y squared minus 3y plus 2. We need to find the factors of 2 that give me negative 3, which would be 1 and 2. But then because I multiplied by 2 here, we need to go back through divide and reduce. And then any denominator that remains, let's bring it up. And there we go. So that is our factoring for the test. If you still want to see more factoring problems, I will be putting up a video that has our factoring extra practice problems in the workbook. So keep an eye out for that video if you still want some extra factoring practice. Okay, question 4. Question 4 is different than question 3 and all of the problems that we did in question 3 for one very major reason. Instead of just factoring, question 4 actually has a solve for x. Okay, so make sure you know the difference between just factoring and solving using factoring. Okay, if we're going to solve an equation by factoring, we first need to factor. All right, so I have this factoring. I have 3, 19, and 14, and that means there's no common factor. So I'm going to take this 3 and multiply the 14. So that gives me x squared plus 19x minus 42 equals 0. Okay, don't forget that we multiplied by 3. That means at the end we're going to have to go through and divide by 3. So we need to find two things that multiply to get to negative 42 and add to get to 19. Well, that looks like 21 and 2. The 2 is negative because the bigger number needs to be positive. So we have here x plus 21, x minus 2 equals 0. But we did multiply by 3, so let's go divide by 3, reduce our fractions, and then any denominator that remains, let's bring it up. So we end up with x plus 7 times 3x minus 2 equals 0. All right, now we just set each one of our factors equal to 0. That means x is negative 7. And then when is 3x minus 2 equal to 0? Add the 2 over, and then divide by 3. So we have our two solutions because we have a quadratic equation. Okay, on the next problem, it's a little bit different. All right, so for B, we have an x cubed, but let's look at each term has a common factor of x. So I'm going to factor out my x first. That gives me x squared plus 2x minus 15. Then I'm going to factor my resulting trinomial. The factors of 15 that have a difference of 2 are 5 and 3. Notice that this time I didn't write out what multiplies to get to 15 and adds to get to 2. Once you get comfortable, you don't have to write that stuff down. Okay, so what we have here is each one of these factors must be equal to 0. So we have our first factor, which is x equals 0. Then we have 5x plus 5 equals 0. And x minus 3 equals 0. So let's go solve each one of these. We don't really need to solve x equals 0. Here, if we subtract 5, we get x equals -5, and then add the 3 over, we get x equals 3. So there are the 3 solutions. Okay, we get 3 solutions because the problem was x to the third, and that will happen most of the time. Okay, so that is solving an equation versus just factoring. 5 is going to be an application, and you will have an application like 5. You will also have an application like the projectiles, where you're launching something in the air and you have your equation and you just need to set your equation equal to 0. But in this case, we just have a geometry problem. So we're going to be making a new pool in our yard. So we have a nice, fun little swimming pool. Maybe it has like a diving board, who knows? But the area available in our yard is 88 square feet. And its length is 3 feet longer than the width. So if we have a width of x, when the problem says the length is 3 feet longer than the width, that means that whatever my width is, my length is 3 feet more than that. What could be the perimeter of the pool? Ooh, that kind of is a turn. Well, we know what the area is. We know that the area is 88 square feet. And we know that area is length times the width. I actually wrote it width times length, but it doesn't matter. So if this is our area, what we need to do is we have to find the width, we have to find the length, and we use those two things to find the perimeter. Okay, so the reason we would ask for like what is the perimeter is if this were a multiple choice question and we just gave you length and width options, it'd be pretty easy to find the right length and width just by multiplying them. But if we ask for the perimeter, then it involves you not picking the right width and length just from a list of choices. Okay, so we have our area. We need to solve this equation. I'll distribute the x through, and I'm going to subtract the 88 over. And I factor that, I get x plus 11, x minus 8 equals 0. So when is x plus 11 equal to 0? That's at -11 or +8. Okay, we know we can't have a negative distance. So that means that our width must be 8 feet. That's not a very big pool. So if our width is 8 feet, and our length is 3 feet longer, that's 11 feet. All right, so now we just need to find the perimeter. And you can do that a couple ways. If you just want to write 8, 8, 11, 11. Let's see. 11 plus 11 is 22, plus 8 is 30, plus 8 more is 38 feet. So that's our perimeter. All right, so there's a great application problem. So you can kind of see how we use a quadratic equation to solve for what they're asking. All right, that is it for page 3. Let's move on to the last page, which is page 4. Okay, page 4 is not a terribly difficult page, but there's one thing you need to know. And if I were you, I would just kind of get this memorized in your head. It's very easy. It's called the leading coefficient test. And what the leading coefficient test is it's a way to tell the end behavior of our graph. So if our leading coefficient, let's just call that leading coefficient, is positive, or if our leading coefficient is negative, it's going to affect how our graph ends. The other thing that's going to affect it is if the degree is with the degree. If our degree is even or if our degree is odd. Okay, if we have a positive leading coefficient and our degree is even, we are going to rise left and right. So it's going to the sketch will look something like this. I'm not 100% sure if that's exactly what everyone will look like, but we're more worried about what these end behaviors are doing. Okay, they're both going up. Now, if our leading coefficient's negative and our degree is even, we are going to fall left and right. Okay. So it looks something like that. Who knows? But something. Now, if our leading coefficient is positive and our degree is odd, we are going to fall left and rise right. Anything that's negative stays negative. Anything that's positive is going to go positive. Now, if our leading coefficient's negative, it reflects that. We will rise left and fall right. So something like that. Okay, so I'm going to use this chart to just answer the questions about each of these polynomials. So it just says, given the polynomial, state the end behavior of the graph and then sketch the end behavior. You're actually not going to be required to sketch. You will just have to match the graph, which is great. If you know the end behavior, then matching the graph should be very easy. So in this case, my leading coefficient is positive and my degree is odd. So that means that we are going to fall left and rise right. And our graph will look something like this. I'm just taking the sketch directly from the chart. Okay, B. I have a leading coefficient that is positive and a degree that is even. So positive and an even degree means that we are going to rise left and right. So our sketch will look something like this. That. Okay, the third one, our leading coefficient, we have a -8, and our degree is even. So, whoops, sorry. We are going to fall left and right. So our sketch will look something like that. All right, our last one, you probably can get it by deduction, but we'll figure it out. We have a negative leading coefficient. Our degree is odd. And so that means we are going to rise left and fall right. And a little sketch of my graph is there. All right, so in this case, this would be a multiple choice question where you just match each of the things to the right place. That is the test. If you need more factoring practice, I will post that video soon so that you can see. All right, good luck with your studying. I know you guys will all do great and be rewarded according to all of your efforts.